Good afternoon, fellow viewers. Welcome back to Easy Mathematics. We thank God today is Friday. Today too, we are coming to talk about powers of numbers. But under powers of numbers, we want to continue with what we were doing last week, Friday. And last week, we were talking about exponential equation. Exponential equation. So we want to solve two or more examples under exponential equation. And when we meet again, God willing, next week Friday, we'll talk about algebraic expression. So let's revise on one or two examples on what we did under exponential equation last week Friday. So last week, let's say what we talked about, let's say when you are being given, let's say 2 raised to the power n is equal to 8. When you are being given 2 raised to the power n is equal to 8. We call this an exponential equation because this is an exponential number, and because of the equal to sign, it makes it an exponential equation. So we said that when you are being given something like this to solve, since the number here is 2, the base here is 2, and having an exponent which is unknown, we have to make sure and make this number, which is 8, also have a base 2 and exponent of a number. So if I look at this, if this is my base and the base is 2, I'll ask myself, then 2 times 2, how many times will give me 8? If you try to multiply and see, 2 times 2 is going to give us 4, and 4 times 2 will give us 8. So it means 2 times 3, 2 times itself, 3 times will give us 8. So this will give me 2 raised to the power n is equal to 2 times 2 times 2, 3 times will give me 8. And that is the same as 2 raised to the power 3. So when you look at this, last week we said that if we are able to get this and the bases are the same, we equate the exponent. So because 2 is the same as 2, I can say that n is equal to 3. So this is what last week we talked about. Today we want to talk about the same thing, but we'll move forward in terms of this exponential equation. Now let's say we have 3 raised to the power x plus 1 is equal to 81. We have 3 raised to the power x plus 1 is equal to 81. Now when you look at the left hand side, the base here is 3. Because the base is 3, then the number here too, we have to make sure that we write this in an exponential form with a base of 3. So what will we do? That means we'll ask ourselves, 3 times 3, how many times will give us 81? So if I have my 3, 9, another 3 will give me 9. And 9 times 9 is what? 81. So this means 81 is the same as 3 times 3 times 3 times 3, 4 times. So this will give me 3 raised to the power x plus 1 is equal to 3 raised to the power 4. It means 3 will multiply itself 4 times to give us 81. If that is the case, after writing this also looks like what we did just here. The base here is 3 and the base here is also 3. So because the bases are the same, what will I do? I will equate the exponent. The exponent here is x plus 1 and the exponent here is 4. So because the bases are the same, I can say they will cancel out, and I will have my exponent as x plus 1 is equal to 4. And this becomes a linear equation for me to solve. So what do? I want x is equal to, so if I cover this one, I'm going to have x is equal to 4. So I have x is equal to 4. Now, the plus 1 will have to join the 4 here. But because the sign here is positive, and this is equal to, the plus sign will change to minus after crossing the equal to sign, which will give me -1. And this becomes a simple subtraction for me to subtract. 4 taking away 1 will give me 3. So x is equal to 3 as my answer. So the value of x here is equal to 3. And this is how we solve the exponential equation for something like this. Let's try a similar one. Let's say we have number 3. We have 4x minus 1 is equal to 16. 4 raised to the power x minus 1 is equal to 16. Now, when you look at this, if my base is 4 and the one here is 16, then I'll ask myself, making this one look like this, 4 times 4, how many times will give me 16? 4 times 4 is 16. So I can say this 16 is the same as 4 raised to the power 2 or 4 squared. So what do I have to do? I will change this into an exponential equation by saying that 4x minus 1, which is 4 raised to the power x minus 1, is equal to the 16 that I have here can be written as 4 raised to the power 2. So this 4 raised to the power 2 is the same as 16. So now you can see that the bases are what? The same. So because the bases are the same, I will equate the exponent or the powers. So this is going to give me x minus 1 is equal to 2. X minus 1, that is the exponent here. The exponent is not only x, but the one here is only 2. So this will give me x minus 1 is equal to 2. For the bases, they are the same. So I can choose to cancel out or not pick it. So after getting something like this, I want x is equal to. So if I cover the -1 here, I have x is equal to 2. So I will let the -1 come to the side of the 2. But this sign is negative. When the sign was positive here, when it was crossing the equal to sign, it became negative. So if positive became negative, then negative will become also what? Positive. So that is in mathematics. So because the sign here is negative, when it crosses the equal to sign, it will become positive 1. Therefore, x is equal to 3. I have been able to find the value of x. So the equation can be in this form. Now let's look at the other way where the equation will also change into a reciprocal manner or form. Let's look at the fourth one. We have 5 raised to the power x, is equal to 1 over 25. 1 raised to the power x is equal to 1 over 25. Now, let's cover this. Let's cover the 5 raised to the power x and the equal to sign. With the 1 over 25, we can say that the 25 can be written in an exponential form as in 5 raised to the power 2 in terms of the base, which is 5. So I can say 5 raised to the power x here is equal to, because the base here is 5 then this 25 can also be written as an exponential, as an exponent or a power of number in terms of the base. So this will give me 1 over 5 raised to the power 2. This 25 is the same as 5 raised to the power 2. Now, when we started with the powers of numbers, we said that when a number like this is given, when we have an exponent in this form, we write it reciprocal, or we write it in the negative form with the exponent. So I will say this is 5 raised to the power x is equal to, this is the reciprocal of a certain power of number, and this is the same as 5 raised to the power negative 2. We talked about this in our previous videos when we introduced powers of numbers. So for more examples on how to write something like this to this, you visit our previous video for more examples and solutions on it. That is where the introduction of powers of numbers. So this is the actual number, but here the power is negative. So if you want to write this one, we are going to write the reciprocal of it, which is this. So vice versa, it is this one. So now we can see that the bases are the same. 5, 5. What do I do? Equate the exponent, which is x is equal to negative 2. I don't need to solve anymore or further. So my answer or the value of x is equal to negative 2. And this is the answer, or this is how we solve an exponential equation in this nature. Let's look at the fifth one. Fifth one, let's say we have 2 raised to the power y is equal to 1 over 16. 2 raised to the power y is equal to y. 2 raised to the power y is equal to 1 over 16. When we look at the number here, the base or the power number here, its base is 2. So this 16, we have to write the 16 as a power of number in terms of this base. So you ask yourself, 2 times 2, how many times will give me 16? 2, 2 is 4. Another 2, 2 is 4. 4, 4 will give us 16. So we can conclude that 4 times itself 4 times, 2 times itself 4 times will give us 16. So I can conclude by saying 2 raised to the power y is equal to 1 over 2 times itself 4 times will give me 16. So 2 raised to the power 4. So with this, I can write my power as 2 raised to the power y is equal to, I can write this as 2 raised to the power negative 4. So to change this one, to write it in this one, you just write the reciprocal of it. And this becomes my answer for this one. So immediately I change this one into this. We can see that the bases now are the same. If I want to read, I'll say 2 raised to the power y. If I want to read this one, I'll say 2 raised to the power negative 4, because a power can be negative, not only positive. So with this, I can see that the bases are the same. So what do? I will cancel the powers and equate the x. Sorry, I will cancel the bases and equate the powers, which is y and negative 4. So I will conclude by saying that, therefore, y is equal to negative 4 as my answer. So the exponential equation can be given in this nature, can also be given in this nature. Let's look at the last example under the exponential equation. Let's say we have the sixth one, the last one. We have 3 raised to the power x plus 2 is equal to 1 over 81. Maybe this will be the last but 1 over 81. Now when you look at this question, it says that find the value of x. If 3 raised to the power x plus 2, all is equal to 1 over 81. Now when you look at the base at the left hand side, the base is 3. So because the base is 3, you ask yourself, 3 times 3 times 3 times 3, how many times will give me 81? So 3, 3, if you do a rough work here, you can say 3, 3, 9. 3, 9, 27. 27 times 3 is 81. Or 3, 3, 9. 3, 3, 9. 9 times 9 is 81. So for you to get the power for this one, you just ask yourself, the base that I have here, how many times of the base will give me the number on my right hand side? So I can say 3 raised to the power x plus 2 is equal to 1 over 3 times 3 times 3 times 3 is 81. But in terms of powers, I can say all these are the same as 3 raised to the power 4. So I'll just write it here, 3 raised to the power 4. So this being the same as 81, I can write it here, representing the 81. Now with this one, I was taught that if a number or a power is written this way, I can write it by letting the power to be negative or negating the power. So this will give me 3 raised to the power x plus 2, all is equal to 3 raised to the power negative 4. If you have something like this, you just negate the power, then you take away the fraction. So what do I do next? He says that if the base are the same, the base here is 3, the one here is also 3. So I can say the base will cancel out. Now you equate the powers. What do I have? I have x plus 2 is equal to negative 4. X plus 2 is equal to negative 4. If I cover the plus 2, I have x is equal to negative 4. So let's write that one. X is equal to negative 4. Then I will lift the plus 2 to join the 4 at this side because I want to get x is equal to. So now that I have x is equal to, I'll lift the plus 2 to this side. But because the plus is crossing the equal to sign, the plus will quickly change to negative. Then I'll maintain my 2, giving me negative 2. So now I have negative 4, negative 2. I owe 2. I owe another 2. In all, I'm owing 6 series. So I'll say x is equal to negative 6. And this becomes the answer or the value for this one. So the value of x is negative 6. Let's look at the last one under this one. Let's say we have number 7. We have 5 raised to the power 2x is equal to 1 over 25. What has changed here is 2x. Good. So how do I tackle with an exponent having 2x? The same thing, I have 1 over 25. The base here is 5. If the base there is 5, then I have to write this as a power in terms of 5, which will give me 5 raised to the power 2x is equal to 1 over 5 raised to the power 2. Now with this, I can write this as 5 raised to the power 2x is equal to 5 raised to the power negative 2. We agree because we know how to deal with something like this. Now that my bases are the same, what do? I am going to equate the powers. And what are the powers? 2x is equal to negative 2. Now, how will I get my x? Since the 2 is attached or close to the x. To get the x with this, we'll say we divide both sides by the number which is close to x. It is x that we want. So any number or anything that is close to 2 to the x that we don't need, we cancel or divide by that number. So 2 will divide both sides, and we'll say 2 will divide this one, 2 also divide this one. So 2 will cancel 2, I now have x. 2 will also cancel 2, I have 1. And this gives me a final answer of negative 1. So the answer for x here is negative 1. And this is how we do the solution for the exponential equation. Look at the base that is having the power, then the number at your right hand side. Make sure that you write it in the power in terms of the base that you have been given. And this is how we solve any exponential equation. If we are able to understand this, anything that comes in our way, we will be able to also understand and solve it. Thank you for staying tuned. Please, God bless you for watching. And if you are watching this, please subscribe to my YouTube channel so that anytime by the grace of God I release a video, you will all be educative and get the best out of it in mathematics. Thank you for staying tuned and thank you for watching. This is Easy Mathematics. We make it easy and easier for you to read and understand mathematics. God bless you for staying tuned, and God bless you for watching. God also bless you for subscribing to my YouTube channel and hitting the like screen. Thank you very much. See you next week, Friday, for a very interesting topic, which is algebraic expression. We'll talk about the multiplying or the multiplication and division, because we've already talked about addition and subtraction. Thank you. God bless you. See you next week, Friday. Bye-bye.